Yeah? What? Oh. So, you okay, Jesus? Yeah? Okay. What'd you do? A weird noise. Okay. What was that weird noise? Oh, okay. So Leslie, compound interest versus simple interest. Today you have to know the difference between the two. Okay? There's a formula for compound interest, but we don't do that in Cambridge Math. We just do one formula for simple interest. That's it. Okay? Yeah? All right. So, oh, what's the difference? Anybody know the difference? Yes, sir.
Compound is 2 or more, simple is 10.
No, actually it's not.
I guess compound would be like interest built up upon like the principal and it keeps on adding.
This guy. This guy. Dang. Even though you couldn't come up with a good reason why Alexis wasn't here today. Oh, maybe only because you got interrupted. You got that right. Dang, that's good. So simple interest, like you make the same amount of interest no matter how many years it takes. So we calculate in generic, we calculate interest every year. Okay? So if you invested $100 at 10% interest, right? At the end of the first year, you would make $10. Would you agree with that? At the end of the second year, you would make another $10 because it's just that $100 at 10%. And the third year, you'd make $10. Do you follow me? That's called simple interest. Compound interest. If you had at the first year $100 at 10%, you just make $10, right? But the second year, that $100 gets increased. Do you see? In the third year, so you make interest on top of the interest. You're making interest on the interest. Yeah, that's compound interest. It gets added back in. Well, better, Miss Molina? Yeah. So in words, I think you should probably write down what you think compound interest is and simple interest. Whoa. Are we good, Jeanette? Yeah? Ready for the formula for simple interest? All right. Formula. The interest is equal to the principal times the rate times the time. So Monse, the interest is equal to the principal times the rate times the time, and that's in years, usually. Anise, what's your shirt say? Sarcasm, just...
One more thing for that.
One more what?
Thing I'm good at.
I'm just learning sarcasm. true story, Jeanette. Just figuring it out. Yeah. Okay. Are we good with this? It's really easy. But the hard part is distinguishing what's the difference between compound and simple. So I want to do a little experiment with you right here. You ready? Oh, yeah. You have a choice, Jeanette. So let's say, for some reason, Miss Mangello walks in the room right now and she offers you in cash, right now, today, $1 million. Here you go. Right? Or a magic penny. Now, don't blurt out what you think the answer is. I mean, some people are going to be like, I want the $1 million. I don't even care if it's a trick. Some people are like, I'm going to pick the magic penny because it's a trick. Let me explain how the magic penny works, Tony. Today, the magic penny is only worth a penny. Tomorrow, though, it doubles. Oh. And the next day, it doubles again and again. Every day for a month, it doubles. And at the end of the month, you get whatever the amount that it doubled to is. Does that make sense, Denise? So which one would you pick? The magic penny. Why?
Because it could be worth more than.
Could be, but $1 million is a lot of money. How many of you guys aren't sure what you would pick yet?
Wait, did you say magic penny for a month?
A month.
Well, that's 30 days. It's not that much time to get to a million.
What if we made it 31 days?
Still.
Let's do it for 31 days.
I would probably use the penny, so.
That's a good point. I'd probably lose the penny, so I'm going to take $1 million.
It's still not.
All right. How many guys would like take the magic penny? Just a couple. How many guys would take the $1 million? Miguel, which one are you taking? You're going to give it all to charity?
Take the magic penny.
Magic penny. What about Andrea? Magic penny? Man, $1 million, though, that's a lot of money. Right, Rebecca? All right. So check this out. This is day 1, 2, 3, 4, right? So on day 5, 16, day 6, hey, at the end of the week, you have 64 cents. You are a quarter way through your month. Feeling good about your penny?
Yeah.
Yeah? Confident. Because you think it's a trick. Yeah. Okay. So wait, can you guess how much money this is going to be worth at the end of the month? Like, just take a guess. Like, what do you think? What do you say? $20. Okay, good guess. What do you think? Oh, Jeanette, what do you think?
$2 million.
$2 million. Wow. Okay, what do you think?
It's like
Oh, $500. 20. All right.
maybe.
Anna, what do you think this magic penny is going to be worth? $50. So you're like, you guys are suckers. Yeah, I'm going with $1 million. Right? Okay. What about Monse? What does she think? $30. Okay. Miss Molina, which one did you pick? The penny or the million? The penny. The million. So you're going to have that $1 million right now. You can start spending it. Okay. Because here you have to wait a month. Okay, so that's after 1 week. That's 7 days, correct? All right. Well, on the 8th day, it's $1.28, correct? And then it's $2.56. Is that right? 5/12, 10/24, 20/48, 50/96. 1, 2, 3, 4, 5, 6. And then 1. What's that? $101.92. Wait a minute. After 2 weeks, you got $100. How many of you guys feeling good about your penny? How many of you guys are feeling bad about your penny? Because it's 2 weeks and you only have $100. Wait, you need how many $100 do you need to get to $1 million? 100,000? You think? So you mean 100,000 times somebody would have to give you $100, or would they have to give you 10?
1,000.
How many times does somebody have to give you $100 for you to get to $1 million?
10,000.
10,000. 10,000 times to get 100. So hold on. Here's what we're saying. We're saying if you have $100, can you guys see those numbers?
Yeah.
You're telling me that I'd have to be given that $100 1,000 times
10,000.
to get to $1 million. Yeah, 10,000 times. Look at that. So 100 times 10,000 would be $1 million. So wait, you'd have to have $100 10,000 times to get to $1 million. That's crazy. Wait, 10,000 weeks. It's 52 weeks in a year. Oh wow, yeah, you're dead. Okay, nah, that ain't gonna happen. You feeling good about your penny?
Yeah.
Still, just because contextually it has to be a trick, right? Sure. Okay, let's do the next week. 101.92. Oh, times 2. Aight. Oh, no. Wow, $203. Getting rich. Hate my life. Okay, you're at $10,000 at the end of your 3rd week. You still feeling good about your penny? Man, you are a faithful bunch. How many of you guys are really happy you got the $1 million?
Oh wait, never mind. I see.
Yeah, that's $10,000. $10,345.76. Oh, $13,000. I mixed my zeros and yeah. Oh wow. Okay, so you have $3,000 more dollars, and you could have had $1 million. If you have $1 million, $1,000 is nothing. If you have $1 million, you can spend $1,000 without thinking about it. It won't even bother you. You could be like, you know what, Mr. Brown, here's $1,000. Thank you. But not even mean it, because it doesn't even mean anything to you. It's like, oh, here's my used chewing gum. Huh. So $13,000 at the end of 3 weeks, or you could have had $1 million the whole time.
Should it change? Can I change?
You want to change your?
I'll go to Magic Pen.
You want to go to the Magic Penny? Why?
Because I see what you do.
I'm not doing anything.
It's way more than.
Really? Like why?
Because if you want to try that, it's going to be like 26 something. That times that, 50 something.
All right, so times 2. Yeah, but we only have a few days left.
Yeah, but you already went past $1 million.
But that's only 26,000, and that's only 52,000.
Yeah, but you have 4 extra days. Thank you today.
That's 104,000. That is a lot of money. But you need that 10 times over to get to $1 million. You need that 10 more times, and all I get to do is double it. Huh. Look at that, on the 28th day. Look at that. 1.6 million times the 29th day, the 30th day, and the 31st day. $13 million.
Yeah.
Knowing me, I'd probably go on the day after we're done.
So, Miss Molina, turns out, I don't know, I wrote something down wrong somewhere, but if there was a decimal right there for 0.48, that's how much money you'd have at the end of the 31 days. $21 million. Now, that kind of growth is called exponential. Compound interest is exponential. Linear, like a straight line, like this would be simple interest. And this would be compound. Starts off really, really slow, and then all of a sudden just boom, it explodes. That's how things in real life seem to grow, like diseases, stuff like that. Like seriously, diseases spread exponentially. Like a couple of years ago, they were all worried about swine flu. I don't know if you remember. You were pretty little. Do you guys remember that?
Yeah.
You would have been in like 4th grade or 3rd grade. They were like really worried about it. And it turned out to be that they didn't spread like they thought. But that's how it works. It just starts off like 1 or 2 people have it, and then all of a sudden everybody's dead. That's how diseases grow. They're exponential. And just poof, they explode. It's not good. Yeah. So here's the thing. On your Cambridge exams or your test or your quiz on Friday, you'll be given the same scenario, and it'll ask you to figure out what the compound interest would be versus what the simple interest would be. This one's bigger. And if it's not bigger, you messed it up. Okay? So the reason we did that whole thing with all that money is so you would see that exponential stuff grows really, really fast. And compound interest is like that. Okay? Ready? Yeah or no? Yeah? Ms. Molina, you ready? You sure? Okay. Let's say, I don't know, Jeanette, who? Give me a person. Give me a name. I'm sorry? Esteban. Felipe, what's Esteban investing in? Okay. Oh wait. Let's say for 3 years. The empanadas aren't 3 years old. He earns 10% interest. That's supposed to say interest right there, Felipe. Alright, he earns 10% interest. Now you have to be careful, because sometimes it asks you to calculate the amount after the time. Sometimes it just asks you to calculate the amount of interest. You know the difference? Ms. Banda, if it asks you for the total amount, it would be the original plus the interest. If it just asks you for the interest, then it's just how much interest was earned. Okay, calculate the interest. Aye. We're going to do over here, we're going to do simple. And over here, we're going to do compound. So Esteban invests $1,000 in an empanada stand. Ooh, what kind of empanadas is this place famous for? Cheese. Cheese empanadas. What kind of cheese?
Blue cheese.
Olive cheese.
You don't like those toppings, not all of
I
them.
know, I heard you. I was just being silly.
I'm like this.
Really? So I could go over here and have an American cheese empanada. American cheese is plastic. It's not even cheese. Like Kraft Singles, it's not cheese. It's a cheese product, not cheese. Really? Is there even really such a thing as I guess there could be? Esteban's cheese empanadas. Not good.
Chocolate.
Chocolate. That's pretty good. How about pineapple?
Nah.
No? Oh. What kind do you like? Cajeta. What's that?
It's caramel.
Yeah.
Huh?
It's like caramel.
It's like a Mexican caramel.
Is it all like gold though? Yeah.
Oh, the cheese. Cajeta, the cheese. What?
It's
I'm very confused.
Caramel made out of goat milk.
It's made what? It's what now?
Made out of goat milk.
But what is it?
Cajeta.
Caramel.
You know what? Tomorrow I'm gonna bring you stuff. I'm gonna bring
Wait,
you
what is it made out of? Because every time somebody says it, like,
It's caramel.
oh, caramel. Oh, yeah. I know what it is now. Yeah, caramel. Because every time somebody said caramel, like other people would talk at the same time, and I couldn't hear the word. For a minute, what I heard was Mexican pheromones. Like, wow, that's interesting. Carlos, I don't know.
I'm sure I've tried them, but I can't like.
All right. But yes, you should bring me one. I would like to try that.
I'm pretty sure I have. Okay.
Go ahead.
I'll bring you one.
All right. 3 years, right? Check this out. Our formula, I want to show you where this T comes from. So we're not going to use the T right now. T stands for time. The interest is, so for the first year, right, the first year, that 1 stands for year, principal times rate. So that would be, the interest would be, would it be 1,000 times 0.1? Because 10% is 0.1? Yeah? And that would give you, how much? 100. So the first year you get $100. Is that correct? The second year you could do the same exact thing. Interest is equal to principal times rate. So that would be, that'd just be the same thing, right? Another $100? Is that okay? And the third year, another $100. Because it's the same every year. That's simple interest. So your total would be $300. That's how much interest he would earn on his empanada investment. That's actually a pretty good return rate, 10%.
Not for cheese and
No, 10% is a good return rate on an investment. That's the amount of interest. So that means that he would have $1,300 invested now. Right? Total, because you would get that $300 of interest back. Yes, sir.
I want to just write it like times 3 instead of doing 3.
Yes, you could. You could. And normally that's what you would do, but I want to show you how the compound interest works. Because we don't get to use the formula in Cambridge Math for compound interest. So we kind of have to use this method. We calculate the interest every year and we just have to add it back in though. So for the first year, you know how you got the interest is equal to the principal times the interest, right? Or the interest rate. And that gives you $100. So then your second year, the interest would be $1,100 times 0.10. Do you see where that, do you see why that changed?
Yeah.
That's the tricky part. It gets compounded. So this interest you earned in the first year gets added into the principal. And so now that is $110. Is that right?
Yeah.
Okay. Third year. that right? Did I add it right or wrong? It's good? How much interest is that? So the total interest would be yeah? Felipe, you're good? It's a nice pencil you got there, Felipe. Dixon Ticonderoga number 2. See? No.
20.
Try it, 20. So we doing good or bad?
Good.
Pretty good, right? Okay.